Checking your physique, I don't think I could want you anymore. Chilling with your girl, I'm jealous that I can't just run over and take you on the floor. And I don't wanna cross nobody, I know it's never worth the pain, but I can feel your eyes run down me, and all my sense just floats away.
Hey, what is up? Welcome back. It's episode 36 of Building in Must Minutes, and we are going to continue on from our last episode, digging into ProseMirror. We've been reading through the documentation, we've been figuring out building our transcript editor from scratch, from the ground, and we're going to continue on that. We're going to work on that. We're going to continue working on that. I've got the ProseMirror docs up here. I haven't actually even started our application, so let's jump into that. I'll open Alacrity, however you want to pronounce it, you know, and we'll jump over to our Must Minutes project and we will see what we got going on here. Do we have any stuff going on? Oh yeah, we're playing around with the ProseMirror editor. We will jump into it and we'll spin up bin dev and then we'll just check. Well, we've got so many windows open right now. I don't know. Let's go back. 127001, you know, load up this. Let's go in and see our transcript. This is where we was at end of Friday session. And we're going to continue, right? So we were working through the documentation. We zoomed in quite a lot, but actually let's stay zoomed in because, you know, you want to be able to see it. I can see it, but you want to see it. So we're going to stay zoomed in. We was working through, was it the library manual or was it the reference manual? We wrote library guide or reference manual? I believe it was the reference manual. We do need this, so we do need to zoom out one. We do need to be zoomed out a little bit. Now, is this what we're going through? This looks different, you know, so maybe it wasn't this one. Which one was it? It was this, the library guide. We were going through the guide, and if I remember correctly, we were on the editor state. This is where we was at. We kind of skipped this last one, rebasing, you know, like that was like, it's not something we need for our editor. I'm sure it's interesting, but they specifically say don't bother studying this until you're sure you'll need it. I don't know why they stick this in here. This could have just been a link to say like, hey, rebasing is a thing, go study it later, here's the link, you know, but it's in here. It's not very long, but we're not going to read it because we don't care about it. What we are going to read through is the editor state. We might have done a snippet of some of these things on that episode, but we're going to start there. Before we start there, let's actually just review, right? What did we learn from the last session? If I go to our transcript editor controller, we wrote a stimulus controller. And there was kind of a couple of things in here, right? So there was the, I'll zoom in a bit as well so you can see text in here. So, ProseMirror, this is a stimulus controller, so we import stimulus controller at the top. And then most of this is the ProseMirror stuff. The core of it are these three libraries, state, viewer, model. And so if we scroll down our document, we have our dummy document. This is a JSON representation of our document that we're rendering on the page. It's got marks, it's got blocks in there of paragraphs and stuff like that. We have our schema, which represents the information about kind of the document, I suppose. The document is made up of different nodes and marks. Those are the two different types of things that can be put together in our document. The document must have a doc at the top. That defines like what content can go in the document, and it must have text as well. And that defines what kind of like. That is the leaf node, essentially, the final part of the document. We have the paragraph, which is our own custom thing, but there could be more things in here. It accepts inline content, of which text is one of those. It is part of the group of blocks, which means it can be put into the document because it is also a block. Pass DOM tells it how to pass DOM that gets passed to our editor. So if we copied and pasted a bunch of text, that might come across as HTML, and this would understand how to turn that into a schema. And also, toDOM allows it to render our current document to the editor. Again, marks at the bottom, down here. Marks essentially are things like emphasis, bold, you know, stuff like that. Anything that kind of surrounds a couple of words. And there's a very specific way that these are rendered as well. Unlike HTML, DOM, where you could kind of compose a string of something that's got bold in it in many different ways. You could wrap each letter with the strong tag, or you could wrap the whole word. This will only ever wrap the entire word of unique marks, I suppose. And yeah, and then we've got 2DOM, which turns that into the DOM. So at the moment, this doesn't have a pass DOM. Actually, no, it has pass DOM there, behind. This, again, so when we paste content into here, it'll capture it in there. And then this one, so it knows how to render it. And so that's how we have Hello Beautiful World, because the document at the top and the schema kind of come together. It says we've got one paragraph with the text Hello Beautiful World, and in that text BEAUT is has the type strong mark on it. So that's how that works. Then we have our stimulus controller, which basically has some stuff it does when you connect. If we want to look at the HTML, basically it just has this, and we have some targets. So if we went to, do we have this set up? Not really. Let's get rid of those. And then what are we looking for? Transcription form. So in here we have our data controller, transcript editor, and then we have our data transcript editor target tip tap. So with those two things, we can come back here. We have our transcript editor. We have our targets, tip tap, data and content. You can ignore data and content. We're not actually using those in our controller right now. In fact, I think I might even remove those from here. We'll leave them in. They're not hurting anyone. When we connect, we create a new state. So we take the schema and grab the node from the JSON. So that grabs our kind of, that combines our schema and our document together into one kind of thing for the state. That's for the document. And then we accept our plugins as well, because they are going to manipulate that state. They're going to have direct access to that state, and so they kind of relate together. These plugins are interesting. We've got the history plugin that is persisting all of the stateful changes and then allows us to undo them, replay them, that sort of thing. Key map allows us to pass a kind of string for how we want to modify keys. Mod Z is going to call undo. Mod Y is going to call redo. Mod B is going to call this toggle mark. Now these three things here are interesting. These values are commands, if I remember correctly, and they allow us to apply their functions that take in the kind of view state and view dispatch. You can see down here on lines 99 and 100, we have window.undo and window.redo set to this function that calls undo and redo. And undo and redo just take these view.state and view.dispatch. The key map's kind of doing that for us, you know, kind of behind the scenes. We just pass undo and redo directly. Down here we don't have that, so we are using the view. What's a view? Well, we have the new editor view here. It takes in our tip tap target. So we take a new editor view, pass it a reference to a DOM element. So this tip tap target is an item on my page. It's a div. It takes the state that we just created. And then also down here, we have this little kind of callback that we can tap into dispatch transaction, and we can see stuff being transacted. Everything on the page happens in transactions. And I think the last few things that we read through talked about how those transactions, there's a special one called transform, and those transactions and transforms can have steps made of multiple steps. So we're kind of digging into that, kind of understanding how some of that works in the end of the last episode, and that's up here. Document transformations, you know, we kind of went through here, steps, transforms, mapping, and it talked a lot about all of that stuff. But anyway, let's jump into editor state and figure out that. You know, I'm just looking at my Twitch alerts now. I'm just confused because it says someone followed me 18 minutes ago, but that was before I started. Is that right? I've only been live for 9 minutes. Okay, fine, cool. Anyway, sidetrack. I got distracted there. What makes up the state of the editor or an editor? You have your document, of course. That's also, and also the current selection. There needs to be a way to store the fact that you have a current set of marks. The current set of marks has changed when you, for example, disable or enable a mark but haven't started typing with that mark yet. are those three main components of the state. Blah. My brain is, we're not quite there yet. What makes up the state? Well, you've got your document, current selection, and any changes. Those are the three main components of a ProseMirror state that exist, a state object. The doc, the selection, and stored marks. Stored marks is interesting. Like, I don't quite get my, enable or disable a mark, but I haven't started typing it. I see. So if you say, I want the thing I'm about to type to be bold, that isn't actually in our document yet. So where does it live? It has to live kind of in this stored marks concept that they've come up with. That makes sense. So state really is our document as it is right now. We have some selection on that document, and we also have potentially, not always, some kind of stored marks, which are like, what marks do we want to type right now? Cool. Makes sense. Sweet. Import schema. We don't need to do that because we've been building our own schema, but yeah, state.doc to toString, selection from. Fine, so these are all things which I think if we refresh, we can go over here and look at our console. We can do view, I think was our, view dot selection state, view state dot selection and from, and to. We won't really have a selection right now, but if we moved it to there you go, 12. We selected the word beautiful, and the spaces. We've got 2 from. So from 6 to 17 is where our cursor is selected right now. What else do we have in here? We've got stored marks. None right now. What about if we're here? Do we have none? So it really only is if I was to press. I don't have any way of storing marks right now because what do we have? We've got toggle mark on command B. Is that gonna... there we go, look. So there's our stored mark. So there's what we're about to type is going to be bold. By the time we start typing, the stored marks have gone because it's applied it. It's now in the document. If we were then to not go bold, what happens now? Interesting. What's interesting there is just really interesting, So there's no text there right now, but there is a stored mark, right? Because it knows that we're about to start typing in bold. Now the stored marks are gone, and if we're still bold, if I now press Command B, it's different. So it's null when there's no changes. When I'm clearing the mark out, it's an empty array because there's no more mark. But that is a difference. There is a difference here between null and an empty array in this stored marks. So that's interesting. So those are the three things that we have to think about when we've got the state, we've got the doc, the selection, and the stored marks. Plugins may also need to store their own state. For example, the undo history has to keep history of changes. This is why the active set plugins is also stored in state, and these plugins can define additional slots for storing their own state. So what else do we have on here, right? So we've got view, and we know we've got, we've looked a little bit at kind of, view.state is the one I wanted to look at, not view. Not view. What have we got? So we've got the doc, we've got selection, we've got stored marks. History's got its own little space in here, and config as well. History has a bunch of stuff in there. So we could look at view.state.history. And then this has some sort of data structure in here that it's looking after, That's interesting. It's got history state. Cool. Selection. What about selection? Kind of we get the idea that there's a from and a to, but what's going on with that? ProseMirror supports several types of selection and allows third-party code to define new selection types. I didn't know there was different types of selection you could do. Well, I thought all you could, I mean, I guess you could do a point selection or like a range selection. Is that not it? You know? Selections are represented by instances or of subclasses of the selection class. So it's an instance of a subclass of selection. Like documents and other state-related values, they are immutable. To change the selection, you create a new selection object and a new state to hold it. Yeah, that makes sense, because obviously we've been building this editor in a way where all of the manipulations are immutable and done through kind of actions, which we'll talk a lot about now. That's very similar to Redux, I believe, on some of that stuff. So that makes sense. Selection have, at the very least, start .from and an end .to as positions pointing into the current document. So there's a relationship there between the state selection and the document. Many selection types also distinguish between the anchor, unmovable, and head, movable, side of the document. So those are also required to exist on every selection object. Interesting. We dig into those a little bit, like what's an anchor and a head? Selection's anchor is an unresolved position. Selection's head doesn't really go into much detail on that, but fine, we'll come back to it maybe. The most common type of selection is a text selection. Okay, well that makes sense. Oh, I see. Okay, I see where they're going with the different types. Which is used for regular cursors when anchor and head are the same or selected text. I still don't quite get the anchor and head concept, but fine. Or selected text. Also, like, what's a regular cursor? Both endpoints of a text selection are required to be inline positions, i.e. pointing into nodes that allow inline content. That makes sense. So this is like, hey, I am selecting the text, right? The inline thing. The core library also supports node selections, where a single document node is selected, which you get, for example, when you command click a node. Such a selection range is from the position directly before the node to the position after it. Okay, cool. So this makes sense. I'm trying to work out how, like, every time I command click here, the document size is changing. So I'm curious, you know, like if we look at the selection from and the selection to, we have, like, when we're in here and we do that, we can delete the whole thing. So command click on the paragraph, even though it doesn't highlight it, we have actually selected the whole paragraph. If we press delete, we delete the whole paragraph. If I create a new block, this is a test, another test. If I command click here and delete, it removes that middle one. Okay, that makes sense. And sometimes it's useful to select the whole node. For example, you might want to select the whole person who just recently spoke, and then delete. Or if you're building like an editor a bit like Notion, where you have different blocks on the page, again, would be useful to be able to click the entire block. So that's interesting. Okay, cool. Transactions. Moving on. During normal editing, new states will be derived from the state before them. You may, in some situations, such as loading a new document, wish to create a completely new state, but this is the exception. Interesting, you know? State updates happen. I don't know what that voice was. State updates happen. State updates happen by applying a transaction to an existing state, producing a new state. Conceptually, they happen in a single shot. Given the old state and the transaction, a new value is computed for each component of the state, and those are put together in a new state value. Okay, so there's a bit of an example here with some code. There's a state tr like transaction, you know, that allows us to create a transaction. tr.doc.content.size 25, tr.insert text hello, new state, state.apply, apply the transaction, and console log that state. It's now a larger document. You know, fine. We could maybe play around with that in our editor. We put our cursor there and do let state. Let tr equals tr.state. State.tr, I don't know what. We'll do that. tr.insert text. Hello. State.apply our transaction. Did it not do it? Well, we can see it didn't do it because the document size never changed. But did our tr.doc.content.size change? It is, yes, because it's 46 now. And it was 43? Well, it was 41 rather, yes. The 43 is a number that we added in for the lot, like includes the beginning and end that you can't actually capture. So, okay, fine. But it didn't actually update our editor. Like, it didn't add hello anywhere. Like, and if I did tr.doc.to.json, what does this look like? The 2 paragraphs, the content, hello, another test.hello. You know, okay, fine. So we created a new state here. I guess what happened here though is that we applied the state to the transaction, maybe. I don't know, you know, that's interesting. Transaction is a subclass of transform and inherits the way it builds up a new document by applying steps to initial document. In addition to this, transactions track selection and other state-related components and get some selection-related convenience methods such as replace selection. The easiest way to create a transaction is with the tr getter on the editor state object. Okay, so that's interesting. That's a getter, which means that this could get you a different tr each time potentially, or the same one, or yeah, this creates an empty transaction based on the state to which you can then add steps and other updates. So if I went into our example here and did state.tr.content.size 41, because the state.tr is different each time. Insert text hello. State.apply tr. Still 41, you know, it's not changed because every time you get tr, it's giving you a new transaction object. So this is interesting. That I didn't realize this before. It creates a new empty transaction based on the state. By default, the old selection is mapped through each step to produce a new selection, but it's possible to use set selection to explicitly set a new selection. Okay, I see. So this is doing the mapping for us as well. Like we talked about mapping before in the last one, and that is done for us here. We can also create our own, you know, selection, which we don't need to do, but we could do. Similarly, the set of active marks is automatically cleared after a document or selection change and can be set using the set stored marks or ensure marks methods. Finally, the scroll into view method can be used to ensure that next time the state is drawn, the selection is scrolled into view. You probably want to do that for most user actions. Fine. Like transform methods, many transaction methods return the transaction itself for a convenient chaining. Again, makes sense. We could do tr.delete.insert text, blah, 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 right? You can kind of chain all of those together. That's quite nice. But yes, the key bit here really is the fact that every time you access state.tr, it is an empty transaction. I find that specific detail a bit of a gotcha in this, you know, because you wouldn't expect it to be. You're like, okay, well that's the transaction, then that is the transaction, but actually what it's going to return is a new empty instance it's actually going to get. I would be curious to see that in code, you know, like let's go to GitHub, if I can type properly, ProseMirror state, I believe it will be in, and this will be maybe index, probably state, get tr. There we go. That is interesting. Return new transaction. Okay, well at least we know it now. That's useful to know. Okay, cool. Plugins. I think we finished this bit. Yeah. Plugins. Plugins. When creating any new state, you can provide an array of plugins to use. These plugins will be stored in a state and any state that is derived from it. You can influence both the way transactions are applied and the way an editor based on the state behaves. Okay. Plugins are instances of the plugin class and can model a wide variety of features. The simplest ones just add some props to the editor view. Okay. For example, to respond to certain events. More complicated ones might add new state to the editor and update it based on transactions. When creating a plugin, you pass it an object specifying its behavior. Okay, so the plugin takes some props and like handle key down, you know. Or actually, this is the handle key down is one of the props. So this plugin spec, we can review the plugin spec quickly. So you don't have to pass it props, but they are just the editor props you would like to bind to the editor. You can also pass state that allows it to find a state field to keep its data in. You can key, view, you know, there's a bunch of different things here. When the plugin needs to interact with the editor view or set up something in the DOM, use this field. The function will be called, and when the plugin state is associated, it passes the view, and then you can do something with the view. That makes sense. Makes sense. Okay. I think the plugin bit is interesting because I'm really curious about how we could build something where we really kind of tightly bind or create an interface with ProseMirror through stimulus, because I think that could be quite nice, but I think we'll see. I think we'll have to see how it plays out. Whether we can have like separate stimulus controllers that kind of add functionality, or I don't know. I still haven't figured some of that detail out. But good to know, good to know. Cool. So here they just create a plugin which just handles the key down event, and it says a keyword press and then returns false to say we didn't do anything. And then that plugin is added in. Transaction counter plugin, state, init, apply, value. Value is interesting. It's like value +1. What's when a plugin needs its own state slot, that is defined. Oh, I see, because it'll start with a value of 0. So this is its own state, right? So this just counts every transaction that happens. The apply function will get called and just count them, because it will go 0. Fine. So I guess we could try this. We could have a plugin. Where does plugin come from? You know, plugin class. We just check plugin. ProseMirror state, because it's part of plugin, obviously. We can go in here, plugin. Maybe we just go up here and just do const my plugin, new plugin. Yeah, we'll change that and we'll just paste that in. We don't really do let's. Transaction counter. And then interesting, that actually can just be applied. Window.transaction counter is transaction counter, and then if we head back here, transaction counter is not a function. Do I not need to? I guess I just return it like that. Transaction counter dot. What did they say in the get state? And then you pass it the state, the view.state. Free. There's been free transactions. So everyone here and go, hello world. 17. There's been 17 transactions. So that's interesting. There's a way we can create our own plugins. We can tap into state. We can store state. We can do stuff with the state and apply kind of things that are happening. We'll keep it in there for now, but eventually we'll remove that. We don't need that, but you know. Some of those other extensions, plugins, whatever you want to call them, history, key map. Interesting that I've got the key map twice. I could just, base key map is just going to be an object that looks like this, right? I guess I could just as easily do base key map. Something like that would still allow me to do. I mean, what is in the base key map? I don't remember. Console.log this key map, and then we'll see. You know, I want to see what's inside of you. Alt backspace. Oh, like enter. That was what was in the base key map. That's interesting. So like alt backspace, alt delete, alt D, backspace, control, like back delete, enter. All of those kind of command delete deletes the entire thing. If delete, I don't know how that's any different from the other delete, but hey. Control E, don't know what Control E does. Control H. Who knew that Control H deleted letters? I don't know. Anyway, those are in the base key map. Something interesting to know. And yeah, so these are going to be functions that are going to return a plugin, whereas my thing is just a plugin already. That's the difference there. Sweet. Sweet. The plugin in the example defines a very simple piece of state that simply counts the number of transactions. It can apply to state. The helper function uses the plugin to get state method, which can be used to fetch the plugin state from a full editor state object. Because the editor state is persistent, immutable object, and the plugin state is part of that object, plugin state values must be immutable, i.e. change their apply method must be immutable, i.e. the apply method must return a new value rather than changing what's old. They need to change, and no other code should change them. Yes, return a new state for anything that changes if they need to change. And that's in the plugin, right? So they're saying here, we can't just kind of manipulate values. So at the moment we're returning 0, but if we returned an object, we should never go return, like we should never value. It's confusing here. If this was state, right, and then this is our state here as well, we shouldn't ever do like state.value equals +1, because we would be mutating the state, and that is bad. That is bad. It's very bad. But we're doing 0, you know, and we're changing. We're at new stage time. It's useful for plugins to add some extra information to a transaction. Often useful. For example, the undo history when performing an actual undo will mark the resulting transaction so that when the plugin sees it, instead of doing the thing it normally does, changes, adding them to the undo stack, it treats it specially, removing the top item from the undo stack and adding this transaction to the redo stack instead. Yes. For this purpose, transactions allow metadata to be attached to them. That's interesting. That's cool. So we can take the transaction, get metadata for our plugin. Interesting. And in return a value or value +1 or whatever, right? And then we can make transactions that are like special in some way. It's interesting using the plugin as like a reference for this state. Like, hey, like I'd like my state, please. And here I am. Here's my plugin. I guess you could also do this in a similar way where you could just, like the history plugin, I could capture it, be like history plugin, and then get its state in the same way, or set its state in the same way. Keys for metadata properties can be strings, but to avoid name collisions, you're encouraged to use the plugin, plugin objects. I guess, yeah, here, yeah, I could pass in a string, but to use the plugin object, it'll avoid collisions. There are some string keys that are given meaning by the library. For example, add to history can be set to false to prevent a transaction from being undoable. And when handling a paste, the editor will set the paste property on the resulting transaction to true. Okay. So like tr.set metadata, tr.set meta, add to history, false. Cool, we're slowly getting to, we're at the view component. A ProseMirror editor view is a user interface component that displays an editor state to the user and allows them to perform editing actions on it. The definition of editing actions used by the core view component is rather narrow. It handles direct interaction with the editing surface, such as typing, clicking, copying, pasting, and dragging, but not much beyond that. This means things like displaying a menu or even providing a full set of key bindings lie outside of the responsibility of the core view component and have to be arranged through plugins. I'm happy with that. That makes sense to me. Browsers allow us to specify that some parts of the DOM are editable, which has the effect of allowing focus. Yes. And a selection in them, making it possible to type in them. So this is kind of talking a lot about how, I mean, is this a link to MDN? Yes, it is. Content editable. The view creates a DOM representation of its document using your schema's toDOM methods by default and makes it editable. When the editable element is focused, ProseMirror makes sure that the DOM selection corresponds to the selection in the editor state. Okay. When the editable element is focused, make sure the DOM selection corresponds to the selection in your editor state. So it kind of is synchronizing your DOM selection to the editor state document and doing that. It also registers event handlers for many DOM events, which translate the events into the appropriate transactions. For example, when pasting, the pasted document content is passed as a ProseMirror document slice and then inserted into the document. using the kind of to or passed on properties, I suppose. Many events are also let through as they are and only then reinterpreted in terms of ProseMirror's data model. The back browser is quite good at cursor and selection placement, for example, which is a really difficult problem when you factor in bidirectional text. Most cursor motion related keys and mouse actions are directly handled by the browser, after which ProseMirror checks what kind of text selection and the current DOM selection would correspond to. If the selection is different from the current selection, a transaction updates the selection as being dispatched. Even typing is usually left to the browser because interfering with that tends to break spell checking, auto capitalization on some mobile interface and other native features. When the browser updates the DOM, the editor notices, repasses the change content of the document, and then translates the difference into a transaction. Okay. Oh, and this makes sense. The core of this stuff really was referred to up here, right? It handles direct interaction on the editing surface, so typing, clicking, pasting, and dragging. Those are kind of the 5. Is that the 5? 1, 2, 3, 4, 5. Yeah, 5 key like events that the ProseMirror view is really paying attention to. I mean, and that's directly with the editor itself. And then, so the editor view displays a given editor state, and when something happens, it creates a transaction. Broadcasts this. The transaction is then typically used to create a new state, which is given to the view using its update state methods. So, DOM event happens, creates a transaction, leads to a new editor state, gets sent to the editor view. Makes sense. This creates a straightforward cyclic data flow, as opposed to a classic approach in the JavaScript world of a host of imperative event handlers, which tends to create a much more complex web of data flows. It is possible to intercept transactions as they are dispatched with the dispatch transaction prop. In order to wire this cyclic data flow. Hey, got a Redux mention. If your whole app is using a data flow model like this, as with Redux and similar architectures, you can integrate ProseMirror's transactions in your main action dispatching cycle and keep ProseMirror state in your application store. What? That's really interesting. Oh, I see. Yes, because this here. Oh yeah, there we go. There's our new state. The bit that we did earlier. This comes full circle. The bit that we did earlier, where we created a transaction and then called state.apply, that gave us a new state. We then had to pass that state into our view, and the way we do that is by calling update state. But if we were using Redux, we would have some code that looks a little bit like this. We would have our app state, we have our view, and then we'd have a function to update that state. And then at some point, there would be some kind of function that gets called when the state is updated that React would do. And so we would have our update, we'd have our view dispatch, we'd call the update function. We would literally dispatch into Redux. If we were doing Redux, we would dispatch with a type of editor transaction and pass it the transaction. That would then store the state in the editor. Up here, we've got our editor with its state. That again is immutable. We could then say if the editor transaction, well, we can state.editor is state.editor.apply. That gets us our new state. And then after we update, we draw, and we'll update the state on the view directly. Which is the same code here, split, so that the state is all stored in Redux. That is very interesting. I mean, you'd end up with a ton of editor transactions in your Redux state, but you normally end up with a lot of state anyway, because usually each thing. Fine, that's really cool. I didn't know it did that, but they built that in a really interesting way for mapping that state and storing that state wherever you want. I'm curious, like, yeah, you're storing it here, right? I'm kind of curious about, like, what's the representation of these things, because I think view.state obviously is an editor state. It's not, it's got a bunch of stuff around it, right? .to JSON. I wonder if there's like a from JSON. Like, could you parse it? It would be maybe a bit slow. Yeah, interesting, you know. One way to implement update state would be to simply redraw the document every time it's called, but for large documents that'd be really slow. Really slow. Since at the time of updating, the view has access to both the old document and the new document, it can compare them, leave parts of the DOM that correspond to the unchanged nodes alone. ProseMirror does this, allowing it to do very little work for typical updates. This is interesting, you know, it's just kind of clicked with the plugins and the fact that plugins can also store some state. So I have this concept in the editor of speakers, right? There's a bunch of speakers on the right hand side, and I can give them names and they change and whatever, right? The state for Chris being speaker 0 and speaker 1 having a different name when I change the name could be looked after by a plugin. So the plugin would store some state and then it would re-render. That state of the plugin would then be captured by any nodes and then render differently as well. Potentially. We're going to have to keep digging in a little bit, but I think we're starting to see the web of how some of these things connect. And yeah, interesting. So we've got kind of some sort of like DOM diff algorithm here. This is very much like React, right? I feel like we're seeing this editor is basically like someone built React and Redux and put it together in one tiny library that's just focused on rich text editing. I think that's really cool. This is almost, I mean, this isn't so much React because there's no virtual DOM, right? But this is more idiomorph, like the DOM morphing libraries. ProseMirror does this, allowing it to do very little work for typical updates. Yeah, so every time you're updating a paragraph, it's not re-rendering the entire document, it's just re-rendering that one paragraph of the text it's changed in. And perhaps the tree up, right? Like if the paragraph is inside a bigger block or whatever, XYZ. A list item inside a paragraph inside a list item that's inside of a list that's inside of the document, right? In some cases, like updates that correspond to type text, which was already added to the DOM by the browser's own editing actions. Of course, it doesn't even need it, because if you can just let the DOM do it, ensure the DOM and state are coherent, doesn't require any DOM changes at all. When transaction is cancelled or modified somehow, the view will undo the DOM change to make sure the DOM and state remain synchronized. Similarly, the DOM selection is only updated when it's actually out of sync with the selection in the state. To avoid disrupting various pieces of hidden state, the browsers keep along with the selection, such as the feature where you arrow down or up past a short line, the horizontal position goes back to where it was. What? I think I made sense of that. The DOM selection is only updated when it's actually out of sync with the editor. Full stop. That really needs to be a full stop. To avoid disrupting various pieces of hidden state. What's the hidden state? Hey. Your horizontal position go back to where it was. Okay, fine, sure. If you say so. Props is useful, somewhat vague term taken from React. Yeah, it literally is like, hey, they took some of React, some of Redux, some of like DOM morphing libraries, and they were like, alright, we're going to stick all this together. Props are parameters to a UI component. Ideally, the set of props that the component gets completely defines its behavior. So we can add callbacks and editable and whatever, right? As such, the current state is one prop. The value of other props can also vary over time if the code that controls the component updates them. As such, the current state is one prop. The value of other props can also vary over time. That's interesting. Like this bit, the value can vary if the code that controls the component updates them, but aren't considered state because the component itself won't change them. The update state method is just a shorthand to updating the state prop. Yeah, I'm curious about where this is going, because it kind of sounds like you could just manipulate the state. I mean, I guess you could, right? Maybe a good thing here would be to look and see what does update state do. So if we look in github.com ProseMirror state, and then check the not ProseMirror state, ProseMirror view, and check the, what are we checking? The view index, update state, update state inner. That looks a lot more than just a shorthand, but sure. Oh, but there's a set props method. Update the view by updating the existing props object with the object given as an argument. Update up there, and update state inner gets called eventually. So all of these props that we're passing to the editor view, we actually can just update whenever we want by just saying like view.update props. So interesting, you know, like if we go back to we refresh this and we have our like view, let's create a new transaction doing view dot, is it state? Let's just grab the state with view.state. Then we'll go tr is state.tr. We'll do tr.insert text. We're going to say hello. You know, if I didn't accidentally fumble the keyboard there. Hello. We'll do hello just like that. You know. And then we'll do state, new state, or let new state is state.apply the transaction that we created, you know, new state dot size or something, right? $31, fine, you know. And it currently is like 25, I guess, or 26 or something. We have this new state. If we then did view dot update props, is it? What was it called? Oh, it was just called update. And we say, hey, the state is the new state, you know. There's our hello. As soon as we did that, the hello popped in. That's interesting. That's very interesting. Okay, interesting. I don't know what we do with that yet, but, you know, pulling it in. plugins are also allowed to declare props, except for state and dispatch transaction, which can only be provided directly to the view. So this is like a max size plugin. If the document reaches a certain size, you know, it will return true, and then it or false or whatever. It's editable as long as the size is less than the max size. When a given prop is declared multiple times, yeah, that's interesting. Like, I've got 5 plugins and they're all determining when it's editable, like what goes on. How it is handled depends on the prop. In general, directly provided props take precedence, after which each plugin gets a turn in order. For some props, such as DOM parser, the first value is found, but the first value that is found is used and others are ignored. For handler functions that return a boolean to indicate whether they handled the event, the first one that returns true gets to handle the event. And finally, for some props such as attributes, which can be used to select attributes on editable DOM node, and decorations, which we'll get to in the next section, the union of all the provided values are used. Fine. Attributes is being, I guess, like class name and stuff like that, right? Control the DOM attributes, yeah. So it merges them in some way, you know. Decorations, the next bit. Decorations give you some control over the way the view draws your document. They are crafted by returning values from the decorations prop and come in 3 types. Node decorations add styling or other DOM attributes to a single node DOM representation. Widget decorations insert a DOM node, which isn't part of the actual document at a given position. Decorations, that's interesting as well. Like widget, not part of the document at a given position. Potentially, we could use decorations to apply some of these information potentially. I don't know. I guess, like, what's this link? What does that do? A widget to DOM creates a widget decoration. It's a DOM node that's shown in the document at a given position. It's recommended that you delay rendering a widget by passing a function to be called when the widget's actually drawn. Fine. Inline decoration has styling attributes much as node decorations, but to all inline nodes in a given range. Also interesting that this one is specifically interesting because I feel like, again, we talked a lot about using marks to identify the playhead marker, like the current spoken word, and that could be an interesting way of doing that. Inline decorations, because all we really need to do is apply some styles to a specific range or a specific set of words. In order to be able to efficiently draw and compare decorations, they need to be provided as a decoration set, which is a data structure that mimics the tree shape of the actual document. You create one using the static create method, run the document on the red decoration object. What's interesting here is it feels like, I mean, this does take in state. So maybe this gets called every time the state changes. And obviously we could have a plugin. We could create a plugin for ProseMirror, which takes in some DOM element or some subscription or something, and then adds it into the state. It has to apply a state update every time. I don't know. Decorations sound interesting. Let's just grab this purple plugin, you know. Like, what's the deal with purple? What's the deal with purple? again, fonts. I think this is doing like from 0 to the content size. I think like we could do math.max, whichever's the largest of that, to 20. And then perhaps down here we say purple plugin, you know. Decoration set. Oh, of course. I'm just going to assume they come from the decoration and decoration set. I assume they're going to come from the editor view. Decoration set and decoration. Hello, beautiful world. This is my message to all of you. Have I reached 20 yet? No. But yeah. And I kind of expected it to stop being purple. You know, and we're still purple. So I'm a bit confused about what's going on there. Inline decorations. Let's just review quickly the from and to. Also, how does it render this? Has it applied it to the paragraph? It's got spans around stuff. Okay. Maybe math. Oh, min. I want the smaller of the two. Duh. Yes. So if I start deleting text over here, it's like that range is always highlighted. Interesting little plugin, interesting decoration set. I actually think I can do something interesting with this for highlighting the text. Because really I don't want to mark the document in any way. I want to apply decoration to the document. And all I need to do is figure out, okay, I've got these nodes or this block of text or this specific word. Get me the numbers, and then if I can get the numbers, I can get this and I can run that and actually wrap it all in a plugin, and I just have to import the plugin, and actually I think that will work quite nicely. Nice. I'm looking forward to building that out. I think this is going to be the tool that we use for the job. I was looking at marks before, but this is a lot more straightforward. I just have to return a set of decorations. It's going to be a good way of doing it. What on earth is this? When you have a lot of decorations, recreating the set on the fly for every redraw is likely to be too expensive. In such cases, the recommended way to maintain your decorations is to put the set in your plugin state, map it forward through changes only when you need to. Okay, nice. Set.map. I'm curious about like the set tr.mapping, tr.doc. Decoration set create doc and speckles. Speckles is an array. It pushes this set of decorations in. Interesting. We are going to take a quick ad break. I have ad breaks on set to every hour just to avoid pre-rolls, so people don't have pre-rolls when they join, and also gives me a chance to go get a drink, which I'm going to go grab a water. So about 40 seconds I'll head off. Let's see where we get to on this before that time though. I'm a bit confused here. Like this, I mean, this makes sense. Decorations is going to just take some state. Get state. Yeah, okay, it's going to get this state. I'm not sure why it takes in state. I kind of expected it to. Okay, no, yeah, obviously, fine. That makes sense. I'm a bit confused. This line. Where is set? I don't know. We're going to figure it out in a moment. I am going to be right back, and I will see you in a moment. Back. We are back. Cool. So it looks like set is actually the decoration set. Apply TR and set. So map here. Mapping the decorations in response. Oh, I see. So originally it was this, right? It takes some state. No, decorations. Yeah, it takes some state. And it returns decoration. I'm confused, you know. What does this actually do? The plugin initializes its state to a decoration set that adds yellow background inline decoration to every fourth position. Not incredibly useful, but sort of resembles use cases such as highlighting search matches or annotated regions. When a transaction is applied to the state, the plugin state apply method maps the decoration set forward, causing the decorations to stay in place and fit the new document shape. The mapping method is, for typical local changes, made efficient by exploiting the tree shape of the decoration set. Only the parts of the tree that are actually touched by the changes need to be rebuilt. In a real-world plugin, the apply method would also be the place where you add or remove decorations based on new events, possibly by inspecting the changes in the transaction or based on plugin-specific metadata attached to the transaction. Finally, the decorations prop simply returns the plugin state, causing the decorations to show up in the view. Fine, so this is like a map that basically is going to adjust these. These are always going to be in the fourth position, even if you add text before, add text after. Whereas otherwise, they would, without this, if you only had the init, they'd only ever, drift along. I guess that's how that works. That's how I'm reading it. I don't think we need to understand that too deeply right now, but it's one of those things that I think we'll end up coming back to and figuring out. The apply method will also be the place where you add or remove decorations based on new events. So here you would have to, yeah, again, I'm like a little bit, what if I need to add a new decoration like this? Apply is taking this, right? It's the decoration set that we're getting back here. Whatever we returned here is what we're getting here. So we're constantly calling map on it. But I imagine there's also a way on decoration set to call like add and delete. So you can add and delete decorations from that decoration set. So we're storing the decoration set in our state, but then we can apply manipulations to the decoration set and get a new decoration set out the back of it. I think that's how that works. I think that makes sense. We'll come back to it. Node views. This is the one I think that I need to really understand, because I think the node views is where it's going to get interesting in how we do some of this stuff. Because we do, I think, need a node view around speakers. The concept of like a utterance is what I had before. So, there is more than one way in which you can influence the way the editor view draws your document. Node views make it possible to define a sort of miniature UI component for individual nodes in your document. They allow you to render their DOM, define the way they are updated, and write custom code to react to events. So, node views, image node, return new image view. So this is saying the editor view is going to take some node views, and for images it's going to return in this no image view node. Which is going to render an image, right? Makes sense. So TipTap kind of abstracts some of this for us, because we just say, oh, I've got a node and here's my like render node view or whatever in one place. And what we're saying here is, yes, okay, like, yeah, TipTap kind of compiles all this down into one big blob. Actually, when you think about it in ProseMirror, what you've got is the schema. There are images in my document, and here's the structure of them. And then separately, you've got, and here's how I would like to render those images with the node, with this specific editor view. And you could have multiple editor views that render them all in different ways, but the schema stays the same. And so in TipTap, they are kind of the one config, whereas in ProseMirror, they are separate. And it makes sense that they're separate. The view object, for example, defines its own image node, which creates its own DOM node for the image with an event handler, declares stop event. But ProseMirror should ignore events coming from that DOM node. I imagine you can probably take the event there and decide to return true or false. You'll often want interaction with the node to have some sort of effect on the actual node in the document, but to create a transaction that changes a node, you'll first need to know where that node is. To help with that, the node views get past a getter function that can be used to query their current position in the document. Let's modify the example so that clicking on the node queries you to enter an alt text for the image. So, node view and get pos. Fine. And then when you click on the image, it says, prompts you for a new alt text. If you get an alt text, it then dispatches the view a transaction, which is, again, this is creating a new transaction, and that transaction we're going to set node markup the current position of this specific image node. and that is the markup that it's passing, with the alt text being updated. So I guess here, similar, we have a select drop down of the list of speakers. You pick one, it's going to then change the speaker on that specific node. Yes. Okay. This one's going to be interesting, I think, because this is the paragraph view, and we can maybe update this to have some other stuff in it. Set node markup is a method that can be used to change the type or set of attributes for the node at a given position. Kind of covered that. Get pos to find the current position, give it a new attribute object with new alt text. When a node is updated, the default behavior is to leave its outer DOM structure intact and compare its children to the new set of children. Updating or replacing those is needed. A node view can override this with custom behavior, which allows us to do something like changing the class of a paragraph based on its content. Interesting. So we have our node view, paragraph, node, I guess node, paragraph view, constructor node, this.dom equals content.dom equals create. So yeah, okay, fine. Empty with no type is not paragraph, return false. Not really sure about that bit. Like, what's like, why would its type not be paragraph? Content size more than 0, remove the empty, otherwise add the empty to the class list, otherwise it's return true. This DOM is also the content DOM, and so I guess we can do stuff there. This is interesting. I'm going to actually take this. I think I'm going to copy this, and we're going to find a little space to put it. This is getting a little bit chaotic in this file. We're going to tidy it up soon, I promise. But we're going to take our paragraph view. I don't think we're going to do this. I don't think that is what we want to do. And I also don't feel like that is what we want. Let's do this. We're going to create this .dom.append child content DOM. I don't think we even need that, This .dom.append child, like, let's call this one a span. Or like, actually, let's do const label is document. It's not going to be a label really, it's just that's what we're going to call it. Paragraph, and then we'll do this .dom.append child label, right? We don't need the node right now. We do need to have the brackets, it's not Ruby. And we're going to go down to our view, wherever that was, to node views, paragraph node, terms node view, and we'll pass node in here even though it doesn't do anything with it. And then we'll refresh this paragraph. Hello, this. And this paragraph up here is not selectable because it's not editable. But these content nodes are. Nice. So now we have this ability to render custom DOM. This allows us to map manipulations to it as well. Images never have content, so in our previous example we didn't need to worry about how that would be rendered, but paragraphs do have content. We kind of skipped over this a little bit because I just kind of knew from TipTap that there's some overlap here, but essentially there is the DOM and then there's the content DOM keys that I set on my view. This.DOM and this.content DOM, and the content DOM will get picked up and be used to render the contents of the paragraph view, and the DOM is obviously the thing that's getting attached to the point. So there's kind of two separate handles, I suppose, that ProseMirror grabs hold of to be able to do stuff, and those are the two handles. You can let ProseMirror library manage it, or you can manage it entirely yourself. If you provide a content DOM property, the library will render the node content into that and handle content updates. If you don't, the content becomes black box to the editor. How you display it and let the user interact with it is entirely up to you. So it's like, hey, you just got a box. I do have content inside this, so that's what we're doing. In this case, we want paragraph content to behave like regular editable text, so the content DOM property is defined to be the same as the DOM property. The content needs to be rendered directly into the outer node. The magic happens in the update method. Firstly, this method is responsible for deciding whether the node view can be updated to show the new node at all. If the new node may be anything that the editor's update algorithm might try to redraw here. I guess that is why, like, if I don't set it, it will call the constructor every time and reconstruct a new view. That's quite expensive. But if I go in here and then did if it's not a paragraph anymore, we can't render this. We're going to return false. It's got to deconstruct the view. It's going to replace it with a new view of whatever node type it's now going to be, because we've changed node. Otherwise, I don't really have anything in here that's dynamic, so I don't need to re-render. But if the list of people changed or something like that, then I would want to reconstruct the select element. And so that might be something that I would do in here. At the moment I don't have other types, so like this is kind of redundant because it doesn't, obviously, it couldn't ever become anything other than a paragraph. But that's useful to know. The update method in the example first checks the node as a paragraph and bails out if that's not the case. Then it makes sure that the empty class is present or absent depending on the node of the content of the new node, and returns true. To indicate that the update succeeded, at which point the node's content will be updated. So rather than kind of deconstructing and rebuilding this every time, you can just apply your updates and patch the node to be whatever it needs to be. Cool, I think we've actually got to the point where we kind of have enough. I mean, there's a few things that we still need to tap into. How far are we on the scroll bar? We've not got far left to go. It looks like we've got commands, and then we're going to touch on collaborative editing. And we don't need to worry too much about collaborative editing. We'll see what it looks like when we get to that point in the guide. But we might have enough to start building something that very closely mirrors what we already had with TipTap, and then to be able to see and compare what those two different things look like. Cool. Looking forward to that. In ProseMirror jargon, a command is a function that implements an editing action, which the user can perform by pressing key combination or interacting with the menu. So I might need to think about commands, because I need some way of updating our state in some specific ways. Specifically, when I need to still figure some way out that either my plugins, it's probably going to be my plugins, update the state, and commands are commands give us an interface for updating the state. For practical reasons, commands have a slightly convoluted interface. In their simple form, they are functions that take an editor state and a dispatch function. So like state and a view dispatch, or some other function that takes transactions and returns a boolean. Here's a very simple example. Delete selection. Oh, that was a horrible. Apparently I've got a timer on that I've been going on my watch for like the last forever. Okay. For practical reasons, yeah, okay, we know they've got a convoluted interface. And what's going on? So they take state, take dispatch. If the selection is empty, it can't delete, returns false. Otherwise, it dispatches our selection, our delete selection command. And it dispatches a transaction for us. That's really what it does. It's just dispatching a transaction for us. It's a little wrapper around that takes the two things. When a command isn't applicable, it should return false and do nothing. When it is, it should dispatch a transaction and return true. This is used, for example, by the keymap plugin to stop further handling of key events when the command bound to that key has been applied. To be able to query whether a command is applicable for a given state without actually executing it, the dispatch argument is optional. Oh, I see. So it doesn't rely on dispatch to obviously return true. It just uses the state. So if you go delete selection and just pass it state and not dispatch, it's kind of going to say, hey. So here, I haven't passed dispatch. This might return true. That makes sense. So this, I guess, is part of the convoluted part. It's like, okay, you need to say if dispatch, because it's an optional argument to the function. The example command should look something like this. Nice. To figure out whether a selection can currently be deleted, you'd call delete selection, pass null, whereas you'd pass the dispatch. Menu bar could use this to determine which items to grey out. Yes, that's interesting. In this form, commands do not get access to the actual editor view. Most commands don't need that, and in this way they can be applied and tested in settings that don't have a view available. But some commands do need to interact with DOM. They might need to query whether a given position is at the end of a text block, or want to open a dialog position relative to the view. For this purpose, most plugins that call commands will give them a third argument, which is the whole view. Okay, fine. So this one, like, actually, this does nothing with the state, does nothing with dispatch. All it does is say, okay, well, if dispatch is available, we're not actually going to call it, but what we're going to do is call the view and do some weird stuff with a view and manipulate it in a weird way. That rather useless. I'd say rather useless. Example shows the commands don't have to dispatch a transaction. They are called for their side effect, which is usually to dispatch a transaction, but maybe something else, such as popping up a dialog. I mean, it makes sense. The commands module provides a number of editing commands, simple ones, variant delete selection command, to rather complicated ones such as join backward, which implements the block joining behavior that should happen when you press backspace at the start of a text block. Yeah, you want to join the two paragraphs together in that case. It comes with a basic keymap that binds a number of schema-agnostic commands to the keys that are usually used for them. Again, we're using some of these. When possible, different behavior, even when usually bound to a single key, is put in different commands. Yeah, fine, makes sense. The utility chain commands can be used to combine a number of commands. They will be tried one after the other until one returns true. I don't know why that would be useful. Oh, that was a sneeze. Cool, dear. Oh, it's still tingling on the top of my nose, that sneeze, really. it gone? I don't really know. My eye's twinging now. Oh dear. For example, the base key map binds the backspace key to backspace to command chain delete selection, which kicks in the node when the selection isn't empty. I see. Okay, that's interesting. That's actually really cool. So backspace is either going to call delete selection, but hey, if there's no selection, it doesn't get called. Delete backward, when the cursor is at the start of a text block, it's going to join. Join backward. It's going to join the two paragraphs together potentially, and select node backward, which selects the node before selection. In this case, schema forbids the regular joining behavior. But none of those apply. The browser is allowed to run its usual backspace behavior, which is appropriate for backspacing things out inside a text block. So actually, like our command, the reason it makes sense now, when we took this command out, even when we don't have the base key maps, we could still delete stuff. And that's because it's just the browser's default behavior. But actually what it wouldn't have done is stuff like joining the paragraphs together, deleting selections, stuff like that, essentially. And so this patches those in. And the default behavior is important so that native spell check doesn't get confused and such, you know. Command modules also export a number of command constructors such as toggle mark, which takes a mark type and optionally a set of attributes and returns a command function. This is kind of a factory method, right, for creating commands for toggling marks. That makes sense. We've got one of those already set up. Some other modules also export command functions, redo, undo. Again, looked at those already. And now we're on to collaborative editing, which we're not really... I'm going to skim over just to see whether there's anything in there that's interesting to us. But I think we can probably get on with just kind of building some stuff, you know. I do want to see like what's going on here. So real-time collaborative editing allows multiple people to edit the same document at the same time. Changes are applied immediately to the local document and sent to peers, which merge in these changes automatically without manual conflict resolution, so that editing can proceed uninterrupted and the documents keep converging. Employs a central authority which determines in which order changes are applied. If two editors make changes concurrently, they will both go to this authority with their changes. The authority will accept the changes from one of them and broadcast these changes to all editors. The other's changes will not be accepted, and when that editor receives new changes from the server, it will have to rebase its local changes on top of those from the other editor and try to submit them again. That's really interesting. It's just like continuously just like, okay, like you win, and then it goes, okay, I'll rebase, and then sends it back, but it's doing it automatically. The role of the central authority is rather simple. It must track a document version, accept changes from the editors when those can be applied, and add them to the list of changes, provide a way for editors. And then this is just a basic, trivial central authority. Collab, and then yeah, interesting. It patches into dispatch transaction, generates our new state, and then sends it to collab. Sendable steps, new state. You know, it sends that new state, and then if it is sendable, if they return back true, then it returns back with receiving the steps that it's supposed to do. And then on new steps push, it will see like any transaction. Yeah, if this is stuff that's just coming up, that's a function that gets called. This is interesting. Like, I wonder if there's a version of this that could use Hotwire or something, or like Turbo Streams to do collaborative editing. I mean, we don't need it for our project, but I feel like there's something interesting there that we could dig into at some point. Cool, that is the guide. We've gone through it. It took us a whole 3-hour stream, another hour and a half. So we've been going on, I guess, 4.5 hours. Just reading through the ProseMirror documentation. Thrilling content, I'm sure. I thought it was actually quite interesting. I think there's a lot that I kind of picked up and learnt in that. I guess now the question is, can we put it into something here? You know, we've got all these bits going on. Can we turn it into something? What can we do with it? I'm curious as well. Like, I thought I could press up and down arrow key. I can press the down arrow key. No? You know, let's do that. So the up and down arrow keys work here, but when I created the node view, the up and down arrow keys no longer work. That was interesting. Something we're going to probably have to fight with, figure out. We did a lot here that was just kind of mess. So I guess we need to tidy up a little bit, and then we'll come back to like some sort of base form. We do not need to have this. We're not overriding our dispatch transaction. I feel like the only reason we'd want to do this is maybe our plugins would want to do stuff here. Maybe, yeah, I don't know. Maybe, like, I can't really see why we want to override the dispatch transaction. Collaborative editing is the only thing that I can really think of. Storing our state somewhere else might be interesting. Don't think we need to worry about it right here. I think we can just delete that. Node views I'll leave in here commented out. We do not need to count transactions. We don't need to toggle the mark of bold, although we'll keep it in because we'll keep some level of basic stuff. We'll keep our paragraph view. We do not need a purple plugin, although that is interesting for the sake of decoration set. Okay. So let's beautiful well, yeah, and then we can delete 7k. We'll just have a simpler dummy document. I think we can come back to a guide. Like, we just copied some of the stuff from the guide, so I think we can come grab that when we need it. Copy that, we'll save that. We will, I think, focus on the node view first. We'll sort the schema out, and then we'll sort the node view out. I think that will be the plan. Work out a schema, then work out the view for some of those elements in the schema. And then, yes, that is the plan. That will be the plan. That is what we're going to do. So we are going to go in here. The schema. Well, schema really is dependent on this blob of JSON I have. I'll show you the blob of JSON. The blob of JSON looks something like $0.value JSON.parse. This is our blob of JSON. And in our blob of JSON, we have segments. you know. And the segments kind of are representing different segments of speech from different people. And at the moment, we have some sort of algorithm that kind of merges all of those up, even if they weren't merged up, you know. I actually think that's done in here, like as part of this. We already have this class here that takes the transcription data in and does some stuff with it. I don't really like how that works right now. So we're going to figure some of that out. This returns like HTML at the moment. It's again, no, no thank you. So we are going to replace this with something else. Do I like segments? So one of the things that I'm thinking about, is that like the any little kind of little thing? Yeah. Right. I don't really use Excalibur very often. Let's see if I can put something together. So we are having a utterance. I want that. Do they have other fonts or is that it? And again, I don't really use Excalibur for this sort of thing very often. Fine. Utterance, you know, we've got utterance. And then I guess segment is another word that like transcript segment. I guess segment makes sense, and it is the word that's being used already. And the segment has items, you know, in here. So the way this works is that the segment has got items. The items are just like 0, 1, 2, 3. So like these items here correspond to kind of items in here, where it has the actual word in alternatives, THI. So for 16, where it says the, you know, that's got confidence of 1. Again, confidence is a concept that I've thrown in. I actually don't know how I want to put that in there, but yeah, I really need to figure out what I want to do with the data structure here and how that all maps together. So we have a word here called world, has a confidence of 0.987, has an end time of 11.13 seconds, a start time of 10.84 seconds. It was spoken by speaker 1. Items is really good for just having a bunch of words, right? But really what is the core of like the layout is the segments. The segments decide when people started speaking or ended speaking. But then the items in here is kind of like you have to combine all of these items together to then get this, which is where the word is. Which means you kind of need to know words that were added in before. Some of this stuff here feels like about the mapping. And the music has stopped. Which means my brain stops thinking, because that's, you know, how it works. So we'll apply a random song. Doesn't matter what it is. It could be anything. Now we have something on. We can get back to it. Now I really just hate this data structure that I get back. This is directly from AWS Transcribe. The way that this is laid out is just a little bit awkward, I find, at times. And one of the things I'm still trying to figure out, I mean, I guess I can get a version of this in fairly quickly, right? Let's have segments. Decoration is declared, but its value is never read. Yeah, okay, fine. Delete 2 there. Delete 2 there. So we have segment. It's going to say hello, beautiful world. I kind of have this set of attributes. There's some way that I need to work out, hey, what word was said when. And I don't really know how to do that yet. I also need to take a quick break. I will be a moment and then I'll be back. I've returned. Right, so the bit that I'm struggling with here is the words. There are many words, and as you add words in, some words will have information about when they were spoken, and some words won't. I don't want to mark every word the way I did before and like wrap each word with a mark, because that requires a lot of processing every time I press enter, or not press enter, but every time I press space or add some punctuation. Like I have to have a whole bunch of logic there about, hey, is this set of text? And really all I want to be able to do is the decoration stuff. Like I want to say, okay, we are currently at this point in time. We're at this point in time in the audio. That correlates to this specific word. And this specific word is at this point in the document. Those are kind of all I want to be able to do. And then the decorations are just going to apply to that range of that word. Yes. That is what I want to do. There is I'm sure there was like a BBC React transcript editor, open source. That's like 5 years old mostly. I mean, there's a few commits from 3 years ago, but it's like 5 years old. It looks like this, right? It's a bit you load demo, and like there's a whole bunch of stuff in here, and some words are like treated differently or something. I don't know why I can't press enter. Again, it's a bit buggy. There's a few, it's not quite right, but I believe this has, well, I'm gonna have to turn the volume off. The ability to, yeah, you see there, it's like highlighting the different words as they're spoken. I'm curious how they're storing that state. Like if you inspect element here, they do have, you know, each word is like marked up with a word. We could put that into our schema. You know. The thing is, like, stuff like heed. Yeah, what about this one? Senses. Is the with the full stop, is that inside the word? It is. Because I guess that schema would look something like, let's just focus in a little bit just on the schema section. Let's just do a new schema. You know, let's create some space in our document. And we'll just say, okay, we've got new schema, you know. And we've got some nodes. And we're going to have a doc node, which is going to have content segment. Plus, it's going to have one or more segments. We are going to have the segment. Are we even going to bother about the group? No, pass DOM to DOM. No, not for this. We can just focus on like what is the content of each one of these. So we obviously know there has to be a text node at the bottom, which has some sort of thing in it that I can't remember what, and it keeps scrolling away. In group inline. Group inline. Like, I have to have that in my document. I mean, even then the group's a bit weird. Like, do I even need the group? Can I not just say, hey, like, there is text? You know, we have text. Yes, we do. We do have text. And we have the segment. It's made up of words. And then this is made up of content, text. You know, oh no, how's the head with rebuilding a rich text editor? It's okay, it's going well. It's actually, I think, simpler now, but I'm still figuring the details out. We were using TipTap before, and underneath TipTap it uses ProseMirror, and I could not see what was TipTap, what was ProseMirror. It was all really confusing, and I've spent the last stream and a half, this stream so far and the last stream, figuring out what is ProseMirror, how does it work, how do I use it, and now I'm rebuilding it using ProseMirror rather than TipTap. And I think it's given me some insight, and I think we've got something that we could probably do here. And what I'm doing right now is I'm just trying to figure out different versions of what the schema might look like for our rich text kind of transcript editor. And what we're saying here is our document is going to contain segments, one or more segments. Each segment is going to include 0 or more, any number of words. And each word is going to contain any number of text, you know. And I think the only bit that I'm kind of not sure yet on here, words have to be in line, like, so we have to just check the state schema. ProseMirror, documentation, schema. It would be good just to see. I don't really want the whole schema. Oh yeah, it's part of that. Node type. Name, schema, is block, is text, is inline, true if inline. So I think I can do is inline true. Words except text and it is in line. Is that correct? Didn't really play around with that. So this now include words with extra punctuation there, or is there a way to have full text output? They are. Yeah, I'm thinking this is like a word is, maybe word is the wrong thing, but yeah, basically anything that it'll include the punctuation. That was one of the issues I was running into before with the old version. Basically, my thinking is anytime we have white space, we create a new word. Word is probably the wrong term here. I kind of modeling this a little bit based off what I can see here with this one that I found online. This is from the BBC, although it's not been updated in like 5 years. They wrap each word with a span, which kind of indicates to me that in their data model they've got class of word on each one of these, even sensors, which has the full stop at the end. And I guess this is slightly different from, I was thinking of using decorations before and then just like selecting that range, but I still need to store the information somewhere in my schema about the word times. Yeah, I remember the issues from before. I just wondered if it might be resolved now. Well, nothing's resolved now because at the moment it looks like this. This is what we've got right now. It's gone. So the hope is it might be resolved. Yes. Also, I guess someone could type that in too. Yeah. So that means whether there's marks. Oh, that's the marks. I'm looking at a node at the moment, not a mark. I feel like a node for each makes more sense. I did them as marks before, but perhaps they should have been nodes. So there's a whole bunch of stuff I can pass into the node spec. Content, which we've set to text or words at the moment. What are we talking about? The word except inline. I guess really this could be like text, right? And then I don't need, in theory, it could be like this. Our document is one or more segments. Our segments are made up of any number of words. Our words is made up of any number of text. And text here could be, it's just text. We're not going to accept any marks right now. We're not really going to accept any groups because we are just specifying the content explicitly of what's allowed. Inline should be set to true for inline nodes, implied for text nodes. So this is inline. I actually wonder, again, minor detail. But does text include numerical values? Yeah, it does. Yeah. Yeah, this is just the default. So ProseMirror forces us to have one called doc, which represents the entire document, and it forces us to have text, which are like the last leaf node in the document, which is just alphanumeric characters, a string of text. Atom can be used to set to true to indicate that though this isn't a leaf node, it doesn't have directly editable content, should be treated as a single unit in the view. This isn't true. We are not an atom. Selectable defaults to true for non-text nodes. I guess selectable should be false here. Selectable false. You don't want to select the word. It should kind of be invisible. It's kind of like any text, but with some extra stuff going on. Draggable, it's not draggable. Code, it doesn't contain code. White space controls the way white space in this node is passed. Default is normal, which causes the DOM parser to collapse white space in normal mode and normalize it, replacing new lines such with spaces. Otherwise, pre causes to preserve the space. Cool, thanks. Used to things being explicit in the values, types from unlimited knowledge. No worries. Yeah, it's just those are the words used by this ProseMirror. So we don't need pre. Normal is the default, we're fine with that. Defining its context determines whether the node is considered as an important parent node during a replace operation such as paste. Okay. If my old schema, my new schema, no, this one we called const my schema equals that, and then up here we have our document, we have our segment, we have our word. So I guess what we're going to do here is try and recreate something similar. Which actually is going to end up looking like this. Type. Was it text? Did I have before? I don't know. I'll go back to it in a second. I installed a new thing today, or this weekend, which is this, and it allows us to step through our undo tree. I haven't fully learned how it works yet, but we can basically go to any point in time in our history of what we did. Yeah, it was text before, and then you can go back. But if I went to here and then decided, oh, actually I want to start doing some stuff, what you'll see here is it creates a new fork in history, so I can actually jump back to different points in time. So I can go back to here. It's quite cool. I quite like having the ability of doing that. So that's that word. This is going to look really verbose in a second. Hello world. That's a handy tool. Wish that could be done on any app, all apps. Yeah. It treats history as this thing that can just branch out, because you can basically go back in time, create a new branch, go forward on it, and go, oh, hang on, there was something in that last bit that I've now can't get back to. And it stores it all. Also, I've also configured it so all of the undo history is stored in a file somewhere. So even when I close the editor down and come back to it, I will always be able to go in here and press space U and it'll have the history there. Yeah, it's quite useful. Oh. So what's going on there? Hello, beautiful world. All right. That's what my document now looks like. If I go up here and refresh, spec.to DOM is not a function. I didn't define my DOM how my schema to turn it into a DOM. So, oh, we do have an ad break at the moment as well. I have to spread this out a little bit. I don't know why I'm using my mouse like a noob. Okay. Just space here, fill format for me. Okay, so I also need to add a toDOM property to these elements. So this has a toDOM. It's going to return that toDOM is going to return the span. So obviously it kind of combines them all together. One of the things I never really captured while I was going through this was how do I save change? Like, how do I track the changes? How do I know? I mean, obviously I must have like the dispatch transaction. There's this. I guess I could look at the editor props. Handle DOM events, handle key down, handle, is this, yeah, view.editor props. The editor view takes some props, direct editor props. It takes a place and then direct editor props. Direct editor props include the state, plugins, dispatch, transaction. And then they also include all of these. Is there one that's just like handle? I'm looking for something that's kind of like on update. I didn't see anything like that. Yeah, I don't see handle DOM events. Curious, what does ChatGPT say? I'm using ProseMirror. How do I get right? maybe there's like on the state, you know, because we create the state. I feel like the editor state is where I would expect to see some of this, like ProseMirror state. Could I subscribe? But the state returns a new state every time. Maybe it is the dispatch. Set up a ProseMirror editor, listen for changes. Doesn't provide a directly on change, but you can implement functionality using a plugin or by wrapping the dispatch transaction method. I thought that might be where we might be going. So we could have a example setup. Assuming you've got your ProseMirror set up, you could create a plugin, your save plugin, and then that is going to say update document changed. View, editor view. Doesn't do anything like that. That code, I get what it's saying. I'm not sure it's right. I don't trust ChatGPT here. So I'm going to check it. I'm going to kind of back it up with the actual documentation. We're going to search plugin system. So it's saying I can pass view and it's going to give me an editor view. That is what it does. It says I return a plugin view update whenever the view state is updated. Okay, fine. So that is actually what it's doing. It gives me the previous state. It gives me the view in the previous state. And then it uses the view.state.doc if it's changed. Console log, fine. So let's just copy this for now. We'll have this plugin. Where was plugin coming from? Was it state? I believe it was. I believe it was. And then we just need to add our like save plugin in here. I don't really like the name, but you know, it's okay. We don't need that. We don't need this. So if the state has changed, if they're not the same, convert to JSON, console log out. I'd quite like that because now I can have stuff over here. And we can check kind of what this looks like. I've obviously just added FF to the end. There it is. Add space. You know, where did that go? It's in here somewhere. Is it in the end of beautiful or the beginning of world? We don't know. The end of world, beautiful. Fine. Got to love double checking OpenAI. Yeah, you never know, you know. They were right in this occasion. Fine, I'll give it to them. It just looked a bit funky. I was like, sus. But they were right, so you know. So this kind of looks right. Just for each word, I am going to have additional information. Like the time it was spoken and stuff like that. I think I'm just kind of thinking about how we do the playhead marker. I think it probably is using the decorations rather than applying a mark. But I think the way the decoration is going to get calculated is based on some metadata that maybe is set on the word or the segment that says it's currently being spoken, like active or something, like some sort of flag that we set. And then we have to query for that somehow, very quickly, so we don't slow down the editor too much. I don't know, I still need to figure that out. It's a bit of a weird one. But we need to first have our data in there. So we have segments, we have words, we have text that make up those words. That is the structure that we have. I'm still like spaces. Like spaces are a weird one. I'm going to take this schema. I'm actually going to, even though I didn't trust ChatGPT before, I'm going to give it this and just say, hey, I'm building a transcription editor. So one of the issues we were having with an XML, after having the weekend break, managed to work out the tags being used was for an incorrect transaction. One of the issues we were having with an XML, after having the weekend break, managed to work out the tags being used was incorrect for transaction. Oh. Sometimes, you know, coming back to it after the weekend, just everything becomes clear. A couple of nights sleep, and you're just like, oh, guys, what's this? What's that? Using ProseMirror. This is my schema so far. I want each word to be separated . I don't want to utilize marks. What's it going to suggest? So for new business transactions, it sends through an open close quote, and they were using it it was a MTA, but the MTA needs a midterm adjustment tag actually to hit the correct flow. Oh. That makes sense. XML is a pain with stuff like that because it's just so easily missed. Okay, they were saying to create a plugin, you know. I think we'd have to create a plugin that makes sure that any white space, anytime you insert white space, you split the words if it's in the middle of a word or stuff like that. Yeah, I'm going to be back. Sorry, typing over my laptop. My laptop's a sentence structure is absolutely shocking right now. No worries. That's fine. Yeah, it took me a little bit of processing to work out what was going on there. A bit like the XML, I suppose. But it's fine. It's not a problem. I'm going to be right back. back. Okay, cool. So what we're doing, we were potentially creating a plugin for this. It seems a bit weird, but we'll come back to some of those. So we'll get rid of the node views. I just want to simplify this file a bit. And I know that I've got my undo tree, so I'm actually okay with just deleting stuff. Okay. Let's create another plugin. Const text. So it's going to return true, which means any other plugin that tries to handle text input is going to get cut off, which is a weird thing about plugins. Word rules plugin, I don't know. I haven't really got a name for it. We've got our plugin, and they say props handle text input, because what we're going to do here is we are going to handle text input. And basically this plugin is going to pass to the view a function which should get called and asked to handle the text input. From to text. Okay, so the words is this. Let's just do that for now. Let's just console log what we're putting in. And then we'll apply our words rules plugin down here. And then we'll go in here, space. Document change, type. Oh, handle text input 1818 and then nothing. I wonder if I should JSON.stringify this, because the problem with the text is if it's a space, it's just not going to do anything. So if I went in here and added a space, you can see that there's a space at position 18. I actually wonder, my schema really should say that the segment can contain words or text, because space is a text. So really it's going to be word text, word text, word text. So really what I want to create is something in our schema that looks a little bit like word text, yes, text space, you know. Something looks like that, because now when I refresh, what I get is what I expect. But these like, they're a bit weird. I don't like those. I need to really think about some data structure. Like this data structure kind of works. This is one approach. There's another approach, I think, which doesn't involve mapping all of the words in this way and wrapping them with this information. But I need data structure that's going to support that. I just don't know what that is right now. Can't get my head around that part. This approach, I think there's two approaches, and they're both complex for different reasons, and I just don't know which one's the better way at the moment. The way we did this before was like the input rules, and I think if we go transcription JS, this version, actually it was the utterance node, or the word mark has these rules down here. This set of things, which kind of takes the view from to and text. Like, this is basically the same thing I'm rebuilding, but uses marks to add whatever you are adding to make sure that you're either removing the mark, adding the mark. Mark makes sense here now, because you can find the range that text before and stuff like that. So I need to decide, like, I think I'm getting to the point where maybe, like, there's a few things in here that I think TipTap, or at least some of the work I've done before, which I took from TipTap, which was really this word mark. This is kind of a plugin that's been written that I kind of extracted out from TipTap. This is essentially just ProseMirror code. We grab the view, we grab it, create a new transaction, we resolve from, I don't know what that does, but it's using ProseMirror. Doc.resolve is a ProseMirror function. Text before is some function that gets some content from nodes. Okay, that's like a little helper function from TipTap by the looks of that. And then applies a rule on those, finds the range that rule applies for, and then applies that mark to those. Yeah, rule.handler, it takes it in there, like this like handler takes in the transaction. Interesting. So there is some overlap there, I suppose, to what I'm trying to do here. But here I'm trying to use nodes. There I was using marks. There's some interesting, like, does it make more sense to have this as a mark? They're a fairly complex mark because it's like a range of time, but it works as a mark. Okay, so that's one way. I think the other way that I've been thinking about, I just want to poke around in here a little bit because I'm like, actually, like, what's... Convert draft.js code block into downloadable files. That's not what I want. STT adapters. Convert STT.json into draft.js code block. Sure, like that. Amazon Transcribe is one of their supported things. Amazon Transcribe to draft. So it takes in Amazon Transcribe. We are going to have to probably write one of these for our schema. But let's just see what they did. So they have text, data, words, paragraph.text.join everything by space. They just have text as like a paragraph. I have this data with the words. And then it returns those results. How did we get paragraph.text? Words by paragraph. Speaker segmentation. Group speaker words in paragraph. So it takes in a bunch of words with remapped punctuation, temp words, takes all of the items, map punctuation items to words. What does that function do? So they remove all of the punctuation. Dirty array is a words map. Previous word is an object. If the word type is punctuation, items to remove pushes the index, and then the previous word fine. So this is going through all of the words and stripping the punctuation and putting it into the previous word, because punctuation becomes part of a word. Fine. And then that's what that does. That's what's going on there. So it takes in all of the items, transcription items, the words, and folds in any punctuation into those words. I wonder what happens with like space dash space. Like that's a weird one, but could be there, right? Like that is valid. Perhaps not in transcript, but you could put it in there if you wanted to. Highlight a pause or something. Fine. And then so paragraph is this bit. We're grouping the speaker words in paragraphs. Group words by speaker. So then you get words, text, speaker. Words, text. Text obviously, but then becomes just like each actual string of text from each. Normalized word. Where's that coming from? Here. Normalized words so they can be used in the generate entities ranges method. Start, end, text, and confidence are the things that we have for each word. I'm curious on here, like at this point we have text type. So this is draft.js. This is a different library of some kind. It's a React based framework we're not going to get into learning this one, but what I would like to know, very briefly, very quickly, is what does like their data structure look like in terms of the state? Entities. I don't really care about entities. Draft, JS, JSON, state, like what does that? Okay, fine. I don't really care too much about what it looks like exactly. It sounds like it looks something like this: text, type, data. Data is essentially attrs, text is kind of content, right? And type is the type. Entity ranges. The entities as ranges are each word in the space joined text. So it needs to be compute for each, the offset from the beginning of the paragraph and the length. What does this do? List of words. Word attribute, punct or text. Attribute for the word object containing the text. Punct hello. Text hello. And then this returns a new map where the offset is saved. Helper function to generate draft.js entities. Okay, so that sounds like a separate concept. Entities. Entity should be created using create entity which accepts three properties and argument, content, state. An entity is an object that represents metadata for a range of text within a draft editor. Its three properties are type, link, mention or photo, mutability, denotes behavior of range of text, and data. Option record containing metadata for the entity. I see, so this kind of is like marks, I suppose. They have decorators for those as well. This is version 1 of our document that looks like this, right? Where we've got these spaces. Version 2 sees a bit of a flatter structure. Where const alt or dummy document 2 type doc content is an array, where you have type type segment, content again is an array. Don't do that. Content is an array. just have commas everywhere. Type is text. Text is like hello. Marks. Type. Word. Right? Like we have a punctuation mark, a word mark, all of those sort of things. And then this would have like start 0, end 5, whatever, right? But let's not worry about what that data looks like right now. But you'd have that. And then you'd have, yeah, you'd have something that looks like that. Not sure why it never bothered to close that, but there it is. So it's flatter, but you still have random text blocks that just represent the space, and then some text blocks that are like representing a word, and some text blocks that aren't. So it's a different approach. This is more closer to like the approach that I have with TipTap. TipTap already is kind of set up in the structure. This isn't called segment, it's called paragraph or something else. I can't remember what it's called, but and these aren't called well, I mean they are text, but yeah. And this I think is called word. Yeah, this is called utterance. So this JSON structure is the JSON structure that we have at the moment. The key difference really is that instead of just having a space between some HTML elements that represent each word, we have a JSON object which is type text and has text of an empty space. But that is the difference really. The benefit of using marks here is that it automatically splits them. I don't have to worry about joining the nodes together. Like if I decided to clear this space out, if I wanted to go, actually I'm going to delete the space, hello and world would just become one. No, they wouldn't, because they have different timestamps. They wouldn't suddenly merge. I still have to write a bunch of code to merge those two words. Like hello and beautiful would have to, if I delete the space, they're still independent from one another until their mark is exactly the same. So I would have to go, oh, when I delete the space, I'm joining backwards. Which is, I think, one of the issues I have at the moment when I delete spaces hoping to merge two words together, but that's not what happens. I delete the space and they still have their own marks. They don't become one. So I actually have to override the delete key, like the backspace, in the same way that the base key maps do. Like have a command chain where it's like, okay, well we might want to merge these two or whatever. But we might want to join backwards. we might want to join backwards. And if we did want to join backwards, well, we have to take the start time and the end time of one. Take the start time of hello and the end time of beautiful, and then remove the start and end times of the previous two. And then that would either be in this structure where I have content, each one being text with some of them having marks, or it would be in this data structure where each word is its own type with its own text content. I mean, this feels weird because words are only ever going to have text. So I feel like when I look at these two different data structures, document 2 is probably the one that I'm leaning to with marks rather than having the words as nodes. Like, it makes more sense to me to have words as marks rather than nodes. At least that's where I lean. And that is how I set it right now. But I still have to solve the problem here where when you delete backwards, what happens? I think the only way of deleting backwards is the backspace. So essentially I need to come up with my own set of base key maps for transcription editor. Which are going to override and work out whether I need to merge the marks in some way. Like backspace, oh, is it a space? Yes. Is the words before and after now connected? Yes. Okay, now we need to merge marks. Merge word marks. Merge word marks. Fine. I actually think we're gonna get rid of this. Dummy document 2 becomes dummy document. The schema is now out of date. This now just takes text, right? And now word marks. Is that what I have to do? I don't think I even need a content property. Like, what do I actually need on the mark? Doesn't need anything, in theory, so just 2 DOM. Oh yeah, and I've called it segment here, and it's actually utterance, right? So this changed it back to changing the word segment. I kind of segment utterance, I don't know. There we go. It looks exactly the same, but now technically underneath it has changed. The content is represented in a slightly different way. I actually think this is a bit easier. You can just read through hello space, beautiful space, world. And then each word has its marks where it's going to have some information about the word in that mark. But the content contained within that mark, we've marked this as a word that was spoken. Okay. I want to change the save plugin to be like a changing a word on change equals callback. Oh, no, on change. Yeah, this. I don't know why I made that weird. Callback. Callback adjacent data. And then down here I can just have a on change data. Yeah, don't want making that weird. On change data console.log save plugin is not defined. It's because I changed its name and I didn't delete it. There we go, on change. I want to kind of just throw this up here because it's like stuff that isn't really changing. This is a plugin that I don't need to really ever worry about what's going on in here. It's kind of done for all intents and purposes, I suppose. And then stuff further down is kind of changing. So we've got like the document doesn't change too much. I'm obviously working on that moment. The schema changes even less. I've related to that document. Then I've got this plugin which I'm going to be changing quite a bit right now. And then we've actually got the implementation down here, which is the setting this up. I think I'm going to delete these as well. Try and tidy up the view a little bit. Yeah, that'll do for now. Right. I think the word rules, like to make this schema work, I need to have a plugin which is kind of applying some rules around the marks. And it's kind of what I was doing here, right? Mark.create, add attributes, parse HTML, render HTML, add ProseMirror plugins. There's our plugin. Handle text input. Apply marking. You know, actually, so this is just our thing, right? Why do we need access to the editor? Like, what are we doing with the editor? Is the editor not just the view? Like, why do we have like state.schema? Like, surely is just view.state.schema. Like, there is the schema. Like, so TipTap does this weird thing sometimes where I'm like, why do we have editor and view? Because view contains the same. Like, we could swap this out to view. And then we don't need editor. I mean, this isn't TipTap. This is obviously code that I've brought in from TipTap now and applied some modifications to. So maybe I put that in there. I have no idea. But yeah, it's weird. Weird. If we go back to here and paste in this, details is declared but never read. Change to the bracket. (26J) delete. Did I accidentally miss one button? Yes. Shift V 27J delete. And then in here paste. Shift V. Oh, actually, I just do equals 27J. Got our rules up here. That takes in a transaction, a range, and a schema. And really, it should return the transactions here, should it not? Because no, I suppose because we created our transaction, we can manipulate it. So that's fine. We don't have to return it. The transaction itself isn't immutable. We are mutating the transaction, and then we apply the transaction to get our desired state. So that's how that works. Then the dollars from, I guess it's there. This is going to struggle with get content from nodes because that isn't, like, I've not got that anywhere. Get content from nodes. Like, I don't even know where that's coming from. It would be maybe TipTap, or it might be this is the other thing I'm worried about with TipTap at the moment. I just find that they're becoming a lot more VC backed, and you go onto their page and you're like, it's an open source library, but it's obviously not an open source library. It's pricing. It's free for hobbyists or small teams. Otherwise, $9.99 a month, aren't they? That's not what I wanted. But get text content from nodes to help it. Just grab this. Resolved position. Resolved pos. Where's that? Like, is that used? Oh, that's just a type. I don't really care about the types. I do not care about your types. Okay. There's a lot in this file. This file went from being like pretty clean to like hectic. That needs to be view. I'm not going to grab this. This is going to be view. I'm a bit confused as to why. Like, I need to figure out. I've been trying to update my NeoVim lately, but like, I should get linting about this. LSP info. What's going on? Free clients attached to this buffer. We've got Copilot. We've got TS server, and we've got null ls, and then Ruby ls isn't attached. I wouldn't expect it to be, and neither is emit language server. Again, wouldn't expect it to be. But I would expect this to say, hey, you know, you're trying to access a variable that hasn't been defined. But it doesn't, and I don't know why. So, I don't really want this punctuation, you know. Schema.marks.word.create word. I'm kind of feeling like I collapse punctuation into the words. Fine, let's refresh. Let's see what we've got here. What do we get? We've got content. So this is marking up correctly, and our marks have the type of word, and because these words don't have information about like start and end, if I join this and is, I mean, it would be nicer if I could just console log content. What are we content? Content 0.content, whatever it is. Go down here and just data content 0.content. JSON.stringify null 2. Right, formatted nicely. There we go. Just so we can see it a bit better, you know. If we combine these two words, it gets hello beautiful world. Separate the words, they become separated. It's perfect, it works fine. The bit that gets a bit weird, if I go up here, and I guess actually if I go in here and go test, the marked type word needs attrs. I need to set some attrs for my mark spec. Attrs object attribute spec. How does that work? The default value for this attribute to use attributes have no default, must be provided whenever a node or mark word mark Okay, it's an object, and then if it's optional. Default value for this attribute to use. Attributes that have no default must be provided whenever a node mark that type of. So I have to set them to default as like a thing. So in here I can go attrs confidence type default and then we'll also have like start and end. You know, we'll have those. And then in here, I guess we'll just quickly see what does this now look like when I've got random. I left a rogue. Where is my rogue? Over there. My rogue bracket. As you can see there, like start 0, null. Like actually, like these probably should be null. You know, like they're not actually set. You know, so there we go. We've got attrs on there. So on here, let's add some attrs. Let's add some attrs. Type a word. I don't want another type. So this is the other thing. I actually want to get rid of the type bit in there. But let's say we had start at 0, end 1. He said hello. It took him a second. Hello. I don't know. Is that a second? Hello. 1. I don't know. Attrs starts at 6, ends at 14. It doesn't really matter. Maybe you had a big pause, you know. And then down here, like attrs starts at 15, ends at 20. You know, it's like seconds or whatever. And so when I go in here and join these two words together, it doesn't join the words together. Even though we got rid of the space, put the space back in, the space is there, but I delete. The words don't smash together because they have different attributes. What's interesting here as well is like actually like this doesn't do anything about this. Like this rules plugin isn't actually getting called here, right? When I go in and say I'm going to delete this space, our handle text input doesn't get called because we're not adding text input, we are just removing text input. And at that point it needs to merge these two marks together into one. This is getting a little bit verbose. True to fault. I'm going to delete that because I'm going to get rid of this concept of like the punctuation part. I think I'm going to delete that. Which means that the marks don't need to have that, which is fine. Which means the punctuation can now just be in the word, right? But if I did space, dash space, that's in the space stuff, right? And text is in there. The punctuation just gets merged into whatever. I've got to be careful there though, because this space with the dots in it, needs to get folded back in at some point. Where does it get folded back into? Any non-white space text probably also has to become some sort of node, you know. Non-spoken, like it becomes punctuation, I suppose, again. But in terms of the editor, it's probably easier just to think of it as text, you know, that isn't marked up. We only really care about the words. And we don't really need to come back. I've been thinking about putting it back into the format, but once I'm in this format once, I don't really want to go back to AWS transcribe format. I can actually build that as an exporter from this format into AWS transcribe if I needed it, and I don't really need it. And I could rebuild this with that, because the punctuation in that format also doesn't have start and end time, if I remember correctly. Like, punctuation is just this thing that's there. So I think that's okay as well. Cool. I'm going to be right back again. I have to keep taking breaks today, but I'll be back in a moment. We're back. Cool. Okay, where did we get to? We were trying to work out how to mark up the text. That's what we was doing. And I think we made some progress. We've obviously got some things going on here where we add punctuation now, and that just gets merged in with a word. That's fine. That's kind of what we want. Okay, it's got its own word. 1, 2, 3. That looks cleaner, I think, in terms of that data structure. I think we do need to... Got 222 lines in this file now. It might be getting to the point where we want to, I don't know, perhaps clean some of this up into some separate files. Let's go lib. I think we'll create a new directory here. Not delete. ProseMirror. And then let's go save that as a directory. Yeah, go in here and just create one called ProseMirror helpers.js. Export const on change, and then we'll go up here and just create a import plugin from ProseMirror state on change plugin. I think on change is probably fine, isn't it? Change reporter. Need a name for it, right? Report change, on change, callback change, on change. We'll leave it as on change. We'll go back to our file. We can then just import on change from helpers / ProseMirror helpers. And then we don't need the on change. The other thing that we might grab into there is this like text content from nodes. We'll just export that out as well. I think that's better. And then we'll import the yank inside word. Paste. Get text content from nodes. Comes from helper / ProseMirror. Actually, I don't really like how those helper files, application helpers, time helpers, kind of made sense. I don't know. Do I like it as that? I don't know. I can't say. It doesn't matter. I was trying to decide, do I do helper slash ProseMirror or do I do helper slash ProseMirror underscore help? I feel like the underscore helpers is just a bit. Uh, 31J. I don't know whether it's her. J. Kind of this whole thing. How to organize it. Whether it stays in this file or not. I mean, we've cut down the file a little bit, but. Actually, what if I take this and then delete to N, delete to N, delete to N, export const text input rules new plugin, something like that. Text input rules, and then in here we could do like const word rules is text input rules text input rules. And now I don't need hate it when I fat finger the caps lock button and I get so confused. I'm like, what's going on? Let's change this to word rules is going to be text input rules 19J, 19J. That word marker is really what it's doing. I might have done that too soon because I feel like the plugin here could do other things beyond the input rules. I've made this too generic. So I think maybe we take this back. Maybe we put this somewhere like word marking. I wonder if this sits more in models. No, I think ProseMirror is fine. I just don't really like this being in the lib folder. I think it's one of the things I have weird about this. Word marker. .js. It's not that. I don't know why I pressed it. Alacrity feels like it needs to do that, but it can access it. I don't really mind. Export default. There's the rules. Import word marker from lib ProseMirror word marker. Is that what I've called it? Lib ProseMirror word marker. Word marker. Okay, I mean, I think we've kind of got something that's very similar now to what we had before. In a way, obviously it doesn't look anything similar. Actually making it look very similar is very quick to do. Still need to figure out the backspace. That's one thing I need to do. Tidy that up. I actually do feel like tip tap, like I'm probably going to end up recreating a lot of what we've just done in tip tap. I feel like I'm following the same structure with the schema as I've got in tip tap, and I'm following pretty much like I'm going to recreate what I built in tip tap one for one without tip tap, because I actually don't think tip tap was doing that much for me. That I needed for this specific use case. The schema is pretty straightforward. Like even the segment view, like when I come out to build the node view, like I think that's going to be pretty straightforward. So the other thing for the plugin is ProseMirror commands. Keymap. Base keymap. Oh, I see. It's like, is it Mac? Is it thing based on those? Is this overriding that? Like, it's almost as if for key in PC base map key it takes the Mac base map and adds the keys in. So it's almost like whatever's in here is just going to be overridden by that anyway. Or applied to it, at least, not overridden. Fine, because there's definitely backspace, right? Backspace has this chain commands. I actually wonder if this should like export const input rules plugin. Because actually what I'm looking at now is really the word marking, the marking of the words is a collection of input rules and a collection of like commands that apply with keymaps. I need to override the backspace keys, right? Because what I need to do is do a special command. So I need to come up with some commands, and there'll be some commands that I need to export, or like some sort of key map. Specifically backspace, I think, to deal with this. I think really what I'm exporting, like this is probably an input rules plugin that is just its own thing. Which takes some rules and returns a plugin, right? This is going to export const input rules, word marking input rules, or word marking rules. And then word marking rules, I don't know, input rules, is that right? Input rules, word marking rules, I actually think this should be apply input rules. Apply input rules. Word marking rules. Cool. We'll just wrap up shortly. I was going to get this last thing in. Apply input rules, word marking rules. So then key map and input rules are kind of very similar. Plugins. I kind of want to call it rule map or something, but I don't think it really makes sense. Apply input rules with the plugin. Word marking rules is here. That makes me more want to move this into like a model, which is like word marking. Rather than lib. And then I think we'll have another thing which is like key maps. And then I guess is this exported in some way? This backspace thing? No, it doesn't look like it. But I could access it, right? I can call the previous base map. And I can patch it, and well, these are chain commands, right? Can I chain commands of chain commands? Not sure. I think we're going to call it there for today. I think what we've got. Obviously, I don't get messages for that one because I do, but it's only console logging the first paragraph. So. Yeah, sweet. And then we will continue on this tomorrow, I think. Plan. We'll figure out what happens next. I think, yeah, I think the next thing, but let's leave ourselves a comment or something, right? How did I get there? That's weird. Base.js. I've got a lot of stuff in transit. So I guess what we'll do is we'll add ourselves a little comment that says to do, add a key map, override, delete, backspace to not remove word marks, join word marks when deleting a space. So that's one of the things we'll do. And then to do add node views for segments. And that's going to be fairly close, you know. The segment is the only node view we have. And then yeah, I guess we're gonna have to figure out how we perhaps interact with the view, the editor view. Tap. I think we can do it with a stimulus controller, because I think what we can do is we could do stimulus. We can do, well, we could target it, but there's also, I'm sure there's something. Multiple controllers, naming, registration, registering, preventing registration, triggering behavior, cross controller coordination. Yeah, kind of. It's not really coordination as such. Directly invoking other controllers. Get controller for element and identifier. This to have a target other. So I could get the view of the controller using something like this. This application dot get controller for element and identifier. We grab the target, and then we specify the controller name that we want to access. Transcript editor controller, transcript editor, and then we can call methods on that controller directly, which means we could access the view directly, which means we can access the state and all of that stuff. State, the transactions, break transactions, we could do that from any stimulus controller, which means that we can have a stimulus controller that's directly looking after the thing here and is able to kind of search for words which match and do all of that stuff in that space. I think that's maybe where we're going on that. But we'll build what we've got so far into this new view. Get that merged in. A more simplified, more dignified approach, which uses JSON rather than HTML. That's what we're going to do. We're going to work on that tomorrow. And for now, I'm just going to leave it there. We're going to wrap it up. Let's see. Yep, that's it. I'll see you tomorrow. Thanks for hanging out. It's been a good, productive stream, I think, going through ProseMirror docs, getting it done. Almost 4 hours. See you tomorrow. Bye. And then I press the wrong button again. Bye.